Okay, welcome to Yellow Man Physics. Today what I want to go through is what I call the 3 S's of motion. And what this is a way of linking the resultant force of an object to the motion that that object then performs or undergoes, okay? Strictly speaking, this last one stays the same. I'm going to expand on later on, but just as a starting point, I like to refer to it as the 3 S's whilst we work on understanding it. So before you watch this video, I recommend you look at or you understand resultant force. I've got another video about an introduction to resultant force, and that would be useful to watch before this one. But let's just go straight in with what's going on to Yellow Man here. So 50 newtons to the left, 200 newtons to the right. The resultant force on Yellow Man is going to be 150 newtons to the right. 200 newtons wins, 50 newtons loses, 200 newtons wins by 150. Now, what the exam board want you to be able to do is to link this situation to what happens to Yellow Man, or a car, or a bus, or a train, or whatever that's undergoing this resultant force of 150 newtons. Now, if we then say, right, well, let's just make the situation a bit simpler and just say, replace all the forces with the resultant force of 150 newtons. Now, if Yellow Man was pulled in this direction with 150 newtons, what would happen is his motion is going to change. He's going to do something because there's 150 newtons acting on him. And what that 150 newtons is going to do is it's going to speed him up in this direction. So it's going to speed him up off the page. And he's going to get faster and faster because that 150 newtons is going to keep acting on him and pulling him, okay? And he'll get faster and faster. So this is our first example of one of my S words for speeds up. Now, if Yellow Man was bombing along down the road, somehow like this, okay, and let's just say, for example, he's going along doing 30 meters per second. Okay, nice and happy. But then he catches himself on something like a rope or a pair of fingers that grab onto his leg, and what happens is they exert a force in this direction of, say, 200 newtons. Now, he was bombing along down the road doing some speed, so let's say there was 100 newtons pushing him along. Now, in this scenario here, let's get rid of this here. We need to work out the resultant force again. So the resultant force in this case is 100, 200 that way. The 200 wins, and it wins by 100 newtons. So actually what happens is, even though Yellow Man was going down the road this way, he was quite happy, and then a pair of fingers came in and grabbed his leg and exerted 200 newtons that way, what I'm going to do is I'm going to slow him down. So the resultant force is going to act in the opposite direction to where he's going, and I'll slow him down. So the resultant force is acting opposite. The S word that we're after is slows down, or slow down. Alright. So we've looked at two scenarios. One where the resultant force is in the direction of the motion where he was bombing along, and we said speed up. Now he was bombing along, someone grabs him, exerts a resultant force, so the resultant force is in the opposite direction, so he slows down. Okay. Now the last example, I'm going to have to clean this up, is this one. Yellow Man stood on a chair. Now, in this case, the chair is exerting a force on Yellow Man of, say, 20 newtons upwards. Yellow Man is exerting a force on the chair of 20 newtons downwards. So overall, the resultant force in this case is going to be 0 newtons. Never forget the units. Now, in this case, stood on a chair, forces are balanced, resultant force is 0. The S that we're going to go for here is stays same. What I'm going to do is summarise this. So let's consider these 3 scenarios of the car. Now I'm deliberately saying or not saying what the car is doing. There's a slight trick to this at the end for the stay same one, but let's not worry about it straight away. Let's consider the first car. So 10 newtons to the right, 2 newtons to the left. You can clearly see from my amazing drawing that this is the front of the car, so let's just assume to the right is the direction it's meant to be going. Okay, we could call it the positive direction. 10 newtons, 2 newtons, the resultant force is 8 newtons to the right. It's a positive force, it's in the direction of the motion, that's going to make it speed up, the first S. This car, again, clearly see that this is the front of the car. 5 newtons to the right, 10 newtons to the left. So in this case, the 10 newtons is going to win. So the resultant force is 5 newtons to the left. Now, I'm just going to assume this is the front, the car was moving that way, so it slows down. The resultant force is in a direction opposite to the motion that it was doing, so I'm going to say slows down. And then this last one here, 20 newtons, 20 newtons, the resultant force is going to be 0. And my last S is stays same. Now, this one has 2 options, and this is where things can get slightly confusing. I'm assuming this is the positive direction of motion, but I don't know what's going on. This car could be going along a road doing a speed of say 5 meters per second or something, or it could just be sat there and for some reason they put their foot on the brakes, so the wheels are locked, but they're also revving the engine at the same time, and so the car's pushing with 20 newtons and the brakes are pushing with 20 newtons. So it could be completely still, or it could just be doing a nice happy and what we call constant speed. So for this stay same one, where I go with this is I say you then have to consider what's happening and decide whether, when you say stay same, you mean stationary or, and then it stretches a bit, if I could say same speed, but your physics teachers will prefer it if you say constant speed. But both of these situations, whether it's stationary or constant speed, are examples of the situation stays the same. Whatever the object is, in this case a car, it just carries on doing what it was doing, so it stays the same. If it was going along doing 3 meters per second, and this is the situation, 0 newtons, then it's going to stay the same and carry on doing a constant speed of 3 meters per second. If it was stationary, then this is the resultant force, 0. It's going to stay the same, it's going to stay stationary. Stuff will stay doing whatever it's doing if the resultant force is 0. So, while we're on the subject, we might as well get the really tricky bit out of the way. So I've just talked about the 3 S's, speeds up, slows down, stays the same. We talked about how the resultant force tells us which of those motion words it's going to do. So then we get to this problem. Now this, quite clearly a plane. I'm going to say that this plane is flying through the air. I guess I could try and add some birds or something onto there to show that it's flying. And there's no ground, so it's obviously flying. Now, let's find the resultant force on this plane. In the uppy downy direction, resultant force is 0, 100, 100, balance is all good. In the forward-backwards direction, again, the resultant force is 0. So what is happening here is there's a plane flying through the air with a resultant force of 0. 0 newtons acting on it. And the question that comes up is, well, why doesn't this plane just drop out of the sky then? Because if I'm saying the resultant force on it is nothing, then what's holding the plane up? Now, when we work out the resultant force, we're not saying there are no forces acting on it. What we're saying is, this is what the forces are doing to each other, and overall, this is what the resultant of those forces acting on each other are. So if we could just consider the up and down direction for now, if I forget about this one and forget about this one, this plane's flying along in the air. If we consider the up-down direction, the forces are balanced, the resultant force is 0. So what this means, in the up and down direction, nothing changes. Because remember, 0 newtons means it just stays doing what it's doing. So I'm not saying the plane doesn't have any weight acting downwards, it does. I'm not saying there's not any upthrust from the wings, there is. But they're balanced. So the situation, the plane, carries on as it was. It doesn't plough into the ground, and it doesn't take off even, or go, not take off, sorry, doesn't go even higher. So in the up-down direction, it stays the same. So it doesn't fall out the sky, it just stays doing what it was doing, which was going through the air. If we put the forward and backwards forces back on, let's call them thrust and air resistance. Come to that another time. In the backward-forward direction, the resultant force is 0 again. So all this means is, in the backward-forward direction, it stays doing what it was doing because the resultant force is 0. So if it's flying along at some horrific speed of like 200 miles per hour, it just carries on doing 200 miles per hour. It's not going to speed up, it's not going to slow down. So overall, my plane carries on flying through the sky. If I want my plane to land, then I need to do something to make the resultant force go downwards. In which case, I would have to do something to reduce, say, the upthrust, so that the resultant force was then in a downwards direction, and my plane would then, it would actually speed up in the downwards direction because I had a resultant force in that direction. So this whole add-on to resultant force, this idea of the motion that you get, is really, really important, and it's something that the exam board really like you to be able to do. So they will give you a situation where there's some forces acting on a body, they'll ask you to work out the resultant force, and they'll ask you to describe the motion. And whenever they say describe the motion, they are looking for the words that are speeds up, slows down, and then the stays the same, you have to go with stationary or constant speed, depending on the situation. So I think what I'll do is I'll just draw out a couple of examples for you to have a go at, pause the video, find the resultant force, then see if you can describe the motion. So I'll just draw those now. Okay, so practice, what I've done here is I've drawn 3 boxes. Could have drawn 3 cars, but I'm saving that for another time. So 3 boxes, and for some reason they're driving along a road. So the question says 3 boxes driving along a road. Find the resultant force and describe the motion of the box in each case. So what I want you to do in each of these diagrams, work out the resultant force, and then therefore what is the motion that you get from that. So what S word are we going for, or the special cases of stay same. Pause the video, have a go. So you either haven't paused the video or you've unpaused it. I will never know. But let's go through this. First one, 3 newtons, 5 newtons. This way wins, so we have a resultant force of 2 newtons to the right. That means I have got something that's assuming this is the positive direction. This one is going to be speeds up. Let's go with this one. 8 newtons, 8 newtons, gives me 0 newtons overall. Now this one, I would initially go with stays same. That won't get me any marks though. I need to describe what type of stays same it is. Now the question says it's driving along the road. Driving along implies the box is already moving. If it's already moving and it stays the same, then it's going to do a constant speed. This case here, 20 newtons to the right, 40 newtons to the left. The 40 newtons wins by 20, so I get a resultant force in this direction, that way, 20 newtons. Assuming that this is my positive direction of motion, this case is going to be slows down. Now, later on I might do a more complicated video and with some more complicated examples of this, but for now I hope that this is a good introduction nugget to get you started on something that a lot of students find very tricky. Thanks for watching.